Alright, in this video we are going to be drafting a C-clamp, and it is going to be a relatively basic draft, so it's a good place to start if you are beginning with Fusion 360, or Fusion, Autodesk Fusion I guess it is now. So we are going to start with creating our first sketch, which here we're going to select Create Sketch. I'm going to select my XY plane, and then I'm going to draw the rough shape of my C-clamp body. Now I'm going to start by clicking the origin point. So I've clicked the line. Now I'm going to go to my origin point, so I'm fixed to my origin. Draw my first line, angle, I'm going to click, actually no, that's not what I want, so I'm going to hit escape, Control Z, go back to my line, click and hold to make a radius, line, escape. Now I'm going to hit my Create tab, go down to an arc to create a tangent arc off of here. Select that point. Now, obviously this looks nothing like a C-clamp right now, but once I start adding my constraints and start doing my dimensioning, hopefully everything will look a little bit better. I usually like to start with constraints, so I'm going to start with a horizontal vertical to make sure all of these lines that I need, horizontal or vertical, stay that way. So everything else already looks like it's constrained. Yep, sketch geometry is over constrained, which means that there's already constraint there. I am also going to add right here in this corner, we can see where we have a tangent curve off of this line. I'm going to create another tangent curve there so that that is a constant roll of a tangent. Now this edge and this edge need to be in the same collinear area, so I'm going to hit collinear for those two. Obviously it dragged this thing really far back, so I'm just going to grab this and drag it roughly where I need it to be. It's closer to what I want, and now I will start with my dimensioning. So over here, sketch dimensions in the upper left, I'm going to click sketch dimension and dimension off of the blueprint I have sitting on my desk right now. So it says from this point here to this line here is going to be 0.75. And now the corner here from here to here, 0.5, 0.5. The overall dimension is 2 inches. Brings this way out of whack, so I'm going to drag this back to get it back into the general shape I want. So this radius here is 5/16, and so instead of doing a decimal, I can also just hit 5 divided by 16 for basic math equations, and it is going to auto dimension for me. This distance right here needs to be 0.625. From point here to here, 5 divided by 32. And sketch dimension. This will also be a 5/16, so 0.312. Or again, I could have just typed in 5/16. Now, as I've been moving all of this around, we can see right here that this area came to a point. I don't want that because this is also supposed to be a 1/2 inch by 1/2 inch chamfer, or I mean corner. So 0.5, point to point, 0.5. Get that corner back in there. Now the overall dimension is 3.5 inches, 3.5. And also from this point to this point right here is supposed to be 18 degrees. So 18. So as you can see, as I'm dimensioning this and constraining it, all of these lines are starting to turn white, meaning that I have fully constrained those lines. That is 2.75 and 3/4 right here, 0.75. All right, so that's a lot of dimensions added in, a lot of constraints done, but in the end, we now have all of our lines are white, which means we have fully constrained this sketch. Now that the sketch is fully constrained, I can extrude it to the thickness I need. I can hit Finish Sketch to finish this sketch, and then go over to the Extrude button, or I can just hit E for the hotkey. And from here, I can extrude 3/4, so 3 divided by 4, and it will give me my solid body now. So I'm holding in Shift and then clicking in my scroll wheel to be able to pan around to look at this. So now I have a rough C shape for my C-clamp. That is what I want. Now I need to put the threaded hole through it. So what I can do for this is create sketch, select the top plane where this hole is going to be, and then I'm going to click a circle function and then dimension it. So this hole is going to be for a 7/16 20 NF. So let's see, 7/16-20 NF. Tap drill size. And that is going to be 25/64. So 25 divided by 64. So when I am doing tap drill sizes, I generally don't like to put the size of the tap on there that I'm going to be drilling, because a lot of times I've seen a lot of engineering students or engineers themselves spec out a 7/16, like for this 7/16 20 hole, and they will then put a 7/16 hole into the part, which is absolutely wrong, because your 7/16 hole is going to be oversized for a 7/16 bolt, because you need to go with the tap drill size. So for machining purposes, since I am a machinist over and not an engineer, I always like to put my through hole as my tap drill size. So what I'm going to do is I've put my 25/64 hole. Now I'm going to dimension the location of that hole. 3 divided by 8 for 3/8, or 0.375 if you know the decimal equivalent off the top of your head. So now this hole is turned, or the circle is turned white, which means I have fully constrained it. I'm going to hit E for extrude rather than hitting Finish Sketch in the right and then doing my extrude. I can just hit E to immediately go to the extrude panel. I'm going to select that hole, or that circle, and then just drag down to make a cut. And then I can hit OK, and right there is our extruded hole. Now I'm going to hit Control Z to go back to show you something else. So finish sketch, and once we're there, we can, instead of just extruding a hole through, we can do a select the whole feature right here. So this whole feature allows us to then add specific threaded holes. And so it's going to ask for a sketch or a point. So this center of our circle is the point we want. Drag this over so it's easier for me to see. So by selecting that point, it knows that that is the point where the hole is going to be created. And from here, I can select the type of hole I want. So the hole type, I don't want a simple hole, or I want a simple hole, and the hole is going to be tapped. So I'm going to select tapped, and no thread offset, and it is going to be an angled drill point. For distance, I am going to go just drag this arrow all the way through, and so that is going to allow for my hole to go all the way through. And then I can put in my parameters. So I have 118 point on my drill bit, which doesn't really matter since it's a through hole, and I'm going to be using unified screw threads. So my size is going to be 7/16, and then I'm going to select 7/16 20 NF as my thread type, class 1B, threads right-handed, and then hit OK. So from here, I haven't actually extruded that circle at all. All I did was select a point and then use the hole function to create the threaded hole. So if you are doing something like this, it is very useful, and I also recommend, because it shows there's going to be threads in that hole, which is, hello Luna, yes, it's a very nice bone. Why don't you go somewhere quiet and chew on it. Alright, so we have our hole in there now. It shows cosmetic threads in there, so we know that this is a threaded hole. And when we hit inspect here in the upper center part and select that hole, it is going to show us what our drill diameter is. So it is going to automatically give us our tap drill size, which is nice. So it removes some of that guesswork of having to Google the 7/16 20 tap drill size. So it is a useful function. And once we have it there, the other thing I'd like to do is here on my workflow in the lower bottom is to right click, rename, and instead of hole 1, I'm going to call it 7/16 20 UNF. Tap hole. Enter. So by naming it 7/16 20, when I look through this print and I select that hole itself and it highlights it for me, I can look at that and I know exactly what type of tap I'm supposed to be going back into that hole with. It allows me to remove some of the guesswork from the machining process, because I can look at this, I can see that it has cosmetic threads, I know that it needs to be tapped, but what do I need to tap it? I can do some guesswork based on the tap drill size and get close, but I don't know for sure. By naming it what my tap drill size is, I'm going to save some of that gas road for myself or other machinists down the road. Once I am finished with that, I can look at this piece and I have a lot of sharp edges on that. I don't want these sharp edges. I want these rounded off. So what I'm going to do is use a chamfer function to chamfer all these corners. So when I hit chamfer up here, or in the drop down menu find chamfer, it's going to ask me to select edges or surfaces, and I'm going to select this entire surface as well as this surface here. So once I've selected those two surfaces and then selected how wide my chamfer is going to be, which is a 1/16 chamfer. Seems pretty aggressive, but it's what the print calls out for. Once I've put that chamfer on, you can see that it automatically chamfers all the edges of that surface. So instead of having to select every single line, I can select the face itself and then just chamfer that. I can also add more chamfers in, like I want these two pieces here chamfered. I can select those two lines, as well as this line right here, and then add those in this chamfer window as well. Hit enter, and there we go. We have all of our sharp corners that were on this part chamfered for us. Looks a lot smoother, a lot less likely to cut myself on, which is always a plus. Working in a machine shop, I am always cutting myself on some piece of sharp metal at some point anyway, so that's going to save me a little bit of blood down the line. But that is our vise body completed. Now, we have other pieces that we still need to fabricate, like the foot and the screw. So what we can do is now save this. So I'm going to save and call this, I think I keep calling it vise, but it is a clamp body, and save. Once I'm done with that, I can come up here in the upper right corner, hit plus for a new design, and now I can make my threaded pin that's going to go in there. There are multiple ways that I can draft this. I'll actually show both of the ways. So first is going to be stacking cylinders. So I'm going to select my plane, draw a circle, and so this is going to be a 250 thousandths, 0.25 circle. And I've based it on the origin, which is why it's already white. Hit E to extrude, and that is, let me see how long this is going to be. 3/16, 0.187 tall. Hit enter, and now I have that extruded plug. I can hit sketch again, the top of that cylinder, center diameter circle, make a second circle. This is going to be dimension 0.435. Enter. Extrude. Select the two options, or the two surfaces I want to extrude. And that is going to be 3 inches. Enter. And now for the next piece, again, create sketch. This surface. And circle. Dimension it. That is... Luna, you're making so much noise. Anyway, that diameter is supposed to be 3/4. Enter. Hit E to extrude again. Select the surfaces. 0.75. Enter. Now, that was quite a few different ways. I had to do a extrude, circle extrude, circle extrude, circle extrude. Then I will chamfer the top corner, and it calls for a 1/8 chamfer. And that is going to be our pin. Obviously, that was quite a few steps. There is a simpler way to do this, which is going to be creating a one sketch. And actually, let's sketch it here. And so for this sketch, what I'm going to do is just use a line. So I'm going to start by sketching half a profile. And from here, I can now dimension this. 0.125, 0.75, 0.13. .187. And now half the diameter for the pin I just created. So this was 3/4, for half that is 375. And for something like this, where I don't know a half conversion off my head, which is the diameter was 0.437, I can do 437 divided by 2, and that will give me the diameter. Same with down here. This was 250, which is a 1/8, which is 125, but I can also do 0.25 divided by 2. And that is going to, whoops, not inspect, close. I'm going to collinear. So this face, it's not going to let me do that. I'm going to reference this to the origin point just so it'll stop being blue. Anyway, so now I have a fully defined sketch. Well, almost fully defined. Control Z, don't want it like that. Let me just do a 45. Degrees. All right, so there is a half profile of my pin that I've just finished. So with this half profile, what I can do now is, instead of an extrude like I've been doing, is a revolve. So I can select this revolve, already highlighted this, in the revolve tab right here. I'm making a new body. Now I've selected what I am revolving, and now I need to select the axis. So I'm going to select this center axis. Then it's going to ask me if I want a partial or a full rotation. I want a full 360 rotation. Hit OK. And now I have a second identical pin. So while this took about the exact same time to make either of these, because making circles and dimensioning them is pretty quick and easy, while this one took longer or about the same, it also allowed me to put this all into one sketch. So all I needed was one sketch and a revolve, and it worked. While this one, I needed 3 sketches and 3 extrusions to make this pin. So it is much quicker, or much cleaner, I guess I should say, to be able to use a revolve function. Now, things that have extremely complex geometries, where you're going to have curves and bevels inside of a shaft, a revolve is going to be a much easier function to use rather than this continual stacking of extrusions. So while this stacking of extrusions is a simpler thing to do, the revolve function is a whole lot, going to be a whole lot more beneficial later down the road. So with all that being said, I'm going to select in my workflow down here and just hit delete, and delete all of that work from that other pin because I don't really need it. I have this pin right here. So now that I have this pin, this shaft right here, the 437, is actually going to be threaded. So what I'm going to do is, in my dropdown, I'm going to select thread. Here's in the create dropdown, here is my thread function right here. It's going to ask me what I want to thread. I'm going to select this face, and it is automatically going to say, all right, that was 7/16, and so here's these 7/16 selections. In the dropdown, 7/16 20 is what I'm going to select in the unified screw threads, and hit OK. So now it's given me those cosmetic threads. Really hasn't changed anything. It's really just cosmetic. But again, those cosmetics allow the machinist or engineer who's working this to know that there is, in fact, threads there rather than just having to guess at it. So again, I'm going to go down into the lower left in my workflow, rename, and rename that 7/16 20 UNF. Enter. That way, I know exactly what thread this needs to be threaded. Now that I have my pin body finished, I do need a through hole right here for my T-handle to go through. So this T-handle is just going to be a piece of round stock, so I don't need to really draft that. What I do need to do, though, is create that hole. So if I go to the sketch function, I can see that it is offering me a sketch plane on all of these surfaces. What I can do, the easiest thing to do, is just going to be select my ZY plane right here and draw a hole over here. Now that is beneficial because it's going to allow me to just constrain it from the tip of my pin over here, which is going to be 0.375, and let's see, from this pin over here, so I know this is 1/8, and so that is going to be 0.25, and my through hole, let's see, based on this physical print I have, is going to be 3/16, 0.187. All right, so there is my sketch, finished sketch. Now, if I look at this sketch in a three-dimensional environment, it's actually inside of my part. So when I go to extrude this, it has selected that sketch, and I'm going to pull it through, and it's going to do a cut. But that cut, I need it to go all the way through. So here in my extrude drop-down, I am going to go down to from profile plane, distance, and symmetric. So this means as I drag and make that cut, it's going to make it symmetrically both sides, thus giving me a through hole. And there is my through hole. So I find that is the easiest way to take care of this, but there is another way this can be done by creating construction planes. I'll probably explain that in a video later on in these series. All right, so with that done, I can now save. Probably should be saving more often. I have a bad habit of not saving things and then losing my work. I recommend saving the document as soon as you start. Do what I say, not what I do. And we will call this clamp screw. Once I have that finished, I can go on to my next part, which is going to be the foot that fits onto the bottom of the screw here. So I'm going to new design in the upper right again, and then go to sketch the foot of the clamp. So I'm going to do create sketch, and I'm going to go in my ZY plane because I know I'm going to do a revolve like I was talking about previously, because this is going to be a little more complex of a geometry where the revolve function is going to really show its worth. So I'm going to come up, over, whoops, escape, line, and finish it out. All right, now I'm going to start with my constraints, horizontal, vertical. I know these I want horizontal and vertical. So now I am going to start with my dimensioning. So this dimension right here is a 1/4 inch, 0.25. The overall dimension is 3/8, 0.375. The overall diameter is going to be 3/4. So what I'm going to do now is create a line. When I go to create this line, if we look in our sketch palette right here, we have line type. And what I can do now is use construction lines or center lines. So what I'm going to do is select center line and then draw a line right here. Now this line, obviously it's not dimensioned yet, so it's just free floating. So I'm going to give it a dimension 2. My edge, so the overall is going to be 0.75. Did I give that the wrong? Oh yeah, I forgot the point. That was 75 inches. 0.75. Right, go home. I've lost where I am. All right. Yeah, if you lose your sketch, you can always hit the go home button. Now, since I'm using a center line, when I selected the 3/4 feature, it gave me an overall dimension of 3/4, which is very convenient, so I don't have to do the divided by 2 function that I was doing previously. So now I can bring these around so it's closer to what I was trying to do. Point 118. I'm getting these decimals wrong all the time. 118. There we go. That looks better. And now center line to edge. 9 divided by 16. And to center line, this is going to be 0.25. This dimension right here is supposed to be 45. All right, so by selecting the line type of a center line, that allows me, instead of dividing by 2 like I did on the pin previously, it allows me to skip that divide by 2 function. It's really good when I have something like this where I have a half clamshell kind of thing, and I can then put the line and then put a full diameter. And once I get my sketch fully finished, I can hit the Finish Sketch button. In the upper left, I can go back to my Revolve feature. And now that I have a center line that's been used, the computer automatically recognizes, or the program already recognizes, that since I established a center line, that is what I'm going to be revolving around, and I only have one sketch profile, so that's what I want to revolve. And so it automatically makes this revolved cup for me. So I'm going to hit OK, and there we go. Finish with that, save, call that foot for C-clamp, save, and now I have my foot, I have my pin, and I have my body. So what I like to do from here is create an assembly. New design. And I am going to then import parts. Assemble, insert component. Clamp body, insert. And then from here, it's going to ask me what direction I want. That's fine, since this is establishing my pattern already. And if I look, it shows a little anchor symbol. That means my C-clamp is anchored in place. It's not going anywhere. It's rigid. So upper top in assemble, again, insert another component, clamp screw, insert. So the clamp screw is obviously not the direction I want. So I'm going to grab the little roller here, roll it 90 degrees, and hit OK. So this now is not fixed. It is floating around in three-dimensional space. So what I'm going to do is join it. So up here in the assemble area, I am going to go down to here, which is joints, and select it, or I can hit J on the keyboard for the hotkey. So it's going to ask me in this window, what kind of joint do I want to use? So I am going to select my first component. I'm going to select the center line of this face here and the center of this bore here. This is a fixed motion. It's rigid, which means it can't move at all. I don't want that. I want to do a let's just do slider. It's going to be simplest. And then once I have my slide established in the Z-axis, I'm going to select minimum and maximum and dictate how far that can come in and out. And hit OK. And so now I can move this pin, which technically is threaded, in and out inside of my vise to the range of motion which my pin is going to have. Now I'm going to insert my last piece, which up top, insert component, foot for clamp, insert. Again, I'm going to rotate this so it's at minus 90 degrees, so that's in the direction I want. Hit OK. Hit J on my keyboard for joint. Select my bores, which is going to be this bore right here. Now, if I'm trying to get something specific, I can hold down my left control to move within that cylinder area. So like this cylinder right here, there's a bunch of different points I could select on it. By holding control, it's going to stay on that bore area, which can be useful. But right now I want this. So the motion is always going to fit on based on what was last used. So instead of a slider, I'm going to select rigid, and then it's going to very aggressively shake everything around to show it's fixed together. But that's what I want. Hit OK. And well, I need to change my range of motion a little bit on my slider, but now, actually I probably can just move this. So this is the rigid configuration I just had. I'm going to edit joint, and instead of having it clamped on that face, I'm going to cancel, just delete. Delete. All right. J to join. I'm going to select that internal bore face and this front face here. And that's going to move the clamp back. All right, cool. So this is a very old trade school blueprint is where I got this from. This is actually from the 70s, or what these blueprints that I've been working from are. So this would have been welded welded in place in the shop trade school. But for now, I'm not going to show it being welded, and there we go. Now the clamp's seating properly. So now we have a fully functional digital clamp that moves around, opens and closes as we need. And that is the drafting of a C-clamp from the 70s. Kind of nostalgic, because even though this is from the 70s, they're still using this in trade school, which is pretty funny, but it's a good project and also a good one to show different drafting styles. Anyway, hopefully this was useful for you. I hope I didn't go too fast on anything. If I did, feel free to slow it down or rewind. Anyway, good luck, have fun, hope you learned something.